Hello again, and welcome back to another episode of Adding Game Sounds, where today we're going to be looking at adding a sound of the player falling and hitting the ground, and changing that sound depending on how fast the player's falling. Before we jump into that, however, I just want to quickly show you guys something. Basically, the project I mentioned back in the first episode of this series is this! The FMOD and Unity Fundamentals course. What it is an online educational course that I'm hopefully going to be releasing fairly shortly. I'm not quite sure yet, but I'll keep you guys posted on that. That teaches you how to use FMOD and its API inside C# in Unity in a very streamlined, easy to follow, and way that gets you basically creating your own events and your own interactive systems in Unity as fast as possible. I'll keep you posted, like I said, on my Twitter at HenryScott0 with any new information that comes up, as well as on these videos. I'll mention them from time to time. But anyway, enough of that. Let's jump into the project we're working on today, which, like I said, is the landing sound. So in the last episode, we were looking at footsteps, and we were looking at how we can change our footsteps depending on what material our player is walking on. Since then, I've taken the liberty of going through all of these kind of animations that are associated with our player character. And whenever I see the player taking a step, I've added the event onto it. So for example, let's take the Ellen push. I don't think we looked at that last time, the Ellen push animation. So when she's pushing an object, you can see she's taking footsteps. If I click on the animation tab here and click on one of these events, you can see I've called it play footsteps event. And if I try and click on one, there we go. This is our sort of animation event here. Notice how I've removed the string. I'm no longer passing the event path into our script, which I'll jump into in a second, and I'll explain why I'm not doing that as well. But yeah, what I did off screen basically was go through these animations, and yeah, anyone, for example, say the melee attack where she takes a quick step, any steps in the animations, I've added the animation event to trigger that sound. Another thing I did is found some game objects that the player can walk on, and I've basically added tags to them so that depending on their material, we can, change the sound of our footsteps when the player walks on them. For example, these blocks here, and these are quite clearly made of stone, and the player can walk across them. The layer mask is also set to platform, so our raycast will be checking to see what tag it has. So what I've done is set the material to stone so that it sounds like the player's walking on stone. And I've done the same thing if I come over here for pressure pads as well, because they also have the platform layer mask, as you can see up here. So I've set the tag to material stone, and I've done that on their prefab, which is in the assets folders down here. If I go assets, let's see, where would it be? 2D game kit, prefabs, interactables, and you can see I've got the pressure plate here, which I've set the tag to, and the pushable box, which I've set the tag to. So whenever these game objects are loaded into a scene, they'll have these tags ready to go. Great, so now that we're all caught up, let's jump into FMOD and see what kind of event we've made for the landing sound, which is this here. So before we start playing the event, I need to explain basically what I've done. If I quickly go into our audio bin with Control-3, I'm going to go Ellen, locomotion, ankle. So these two audio files here are labeled Ellen footstep jump and Ellen footstep land. If I play the jump sound, we get that, and if I play the land sound, we get that. So these are obviously intended to be used for when the player jumps and when the player lands. And originally what I did was basically just create two events, one for jumping and one for landing. They'd just play the event. There would be a little bit of volume and pitch modulation, but that was pretty much it. It was nice and simple. Just play one audio file and finish when the audio file was at an end. And that was fine, but it sounded very messy because, well, there was a lot going on. For starters, there was obviously a lot of footstep sounds, as well as the jumping and landing sounds, which sound very similar. It was all being triggered very frequently. As well as that, it sounded very repetitive. Everything sounded too similar. As you can see, we've only got two audio files to work with, one for each. So I wasn't really quite happy with it, to be honest. So what I've done for now is I've got rid of my jumping event. I have, as you can see, made one, but I'm not using it at the moment. Maybe we'll come back to it, but for now, we're just not going to have a sound for when the player jumps. It still kind of works. It doesn't feel too out of place to not have a jumping sound because there's obviously a lot of footstep sounds. If we do later on feel like we need one, we can go back and kind of see if we can, come up with some fix to this issue. But for now, we're just focusing on the landing sound. And what I did for the landing sound is, instead of, in an attempt to make it a bit more interactive and a bit more dynamic, I'm using both of these audio files, basically, the jump and the land sound. One is kind of, I'm using as a softer landing sound, and the other's more harder sound. So if we listen to these again, the jump sounds quite soft, doesn't it? There's not a lot of impact behind it. There's not a lot of low end or weight. Whereas the land sounds a bit more heavier. So if I go into our landing event, you can see I've got both the audio files loaded up here, and I've also got a parameter, and I've called it velocity. If I click on this parameter, open these tabs out, you can see I've automated the volume to kind of fade in and out depending on what value this velocity parameter is at. So it ranges from -6 to 0, and I'll explain how the velocity parameter is going to work a bit more in C# when we get to that. But just know for now, when the velocity is at kind of a higher number, nearer 0, the player is falling at a slower speed. So we want a sort of softer sound to be heard when they hit the ground. So if I put the velocity parameter about there, about 0.05, and play it, we hear, not only do we hear just the soft landing audio file, but it's very, very quiet. Maybe it's too quiet, actually. It might need a bit of adjusting, but for now it kind of works. If we go to, say, -0.3, so the player's falling a little bit faster now, we get a blend of the two. If I then set the velocity parameter to -6 and play that, we get a nice hard fun sound just from the land audio file. And on top of this, I've also added some modulation to both the pitch and the volume for both files to, again, add a little bit of variation so we're not hearing the same sound every time we land. So this is a nice, easy way to add a bit of depth, I suppose, to, you know, anything you've got in your game that might be falling from a height, and that height might change depending on, you know, well, what happens in the game. It doesn't have to obviously be with the player character, but in this case, that's what we're doing. Yeah, that's pretty much everything on the FMOD side. Pretty simple. So without any further ado, let's jump into C# and see how we triggered this event. So here we are in our handy FMOD player script, which we've been using for the last few videos now. This is where we're going to be triggering our landing sound and kind of controlling that velocity parameter that we created. As you can see, one of the first things you'll probably notice that I've changed is I've added a few more variables which I'm going to be using in this video. We've still got the distance and the material float variables. We've got a new one here, a Boolean variable called wasGrounded, currently set to true. I'll be explaining what that does in a little bit. I've also created a variable for the layer mask that we were using in the last video, because in this one I'm going to be using another raycast that is also going to be checking the same layer mask. So in case you're unfamiliar by what I mean by that, check out the last episode where we looked at how layer masks can help us organize our game objects. So yeah, so because I'm using another raycast that's going to be checking the same layer mask, I've decided to store the value of the mask I'm after inside this variable called LM, which I'll be accessing in my raycasts. If I quickly go down to the last raycast we made in the last episode, here we are, this is it. So in the material check function, I've just replaced the value with LM, which will reference the value up here. Cool. We've also got these 3 private float variables labeled height, old height, and height difference. These are what we're going to be using as a kind of simple way to basically measure how fast our player's falling, essentially. Didn't want to go too much into the whole velocity kind of sciencey, physicsy coding side of things, but this, you know, works quite well, and hopefully it'll be nice and easy for you guys to, you know, grasp and get a hand on, so you can use it in your own scripts as well. And we also have a variable called Footsteps, which is going to store the event instance of our footstep sounds. Again, I'll explain the reason why we're now changing how we, you know, trigger our footsteps in a little bit more detail as we go along. So as you can see here, the first thing I'm doing is using the start function, and I'm using the start function to basically store the event path of the footstep sounds into the footsteps variable we just created here. So as opposed to storing this event path in the footsteps variable as soon as, you know, the animation is triggered in Unity and we take a step, we're doing it this way so we can kind of use parameters a little bit differently. Again, I'll explain that when we get to it. But yeah, inside the event, inside the function we created last time called play footsteps event, all we're doing, in fact, let's go to it quickly. All we're doing is just saying footsteps.start, because like I said, in the start function, we've already stored the event path in our variable. Next is the play melee event. Nothing's changed there. Whenever the animation is triggered and we sort of swing that staff, we're going to be playing playing a one shot of the event. Nice and simple there. Then next we've got a few changes in the fixed update function. So the first two parts of it are the same as last time. We're just using a debug to see our raycast we created in the last episode. We're also calling the function material check, which is here, to create a raycast and then check to see if it's the player's on top of a material, and if it is, change the material variable. Blah 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 blah. We did this in the last episode, so go check that out if you're a bit unsure. But yeah, the gist of it is nothing's changed there. However, we're now calling a few new functions which we've created. The first being player landed. So if I quickly go down to where I've created this new function, player landed, I'll explain what it does. So this is the function we're going to be using to play our FMOD event in, essentially. Just to give you a kind of rough idea for now of how it works, in this if statement, we're first checking to see if the player is just landed, essentially, if they're touching the ground and were previously in the air. Then, once we figured out that they have, we're then creating an event instance, we're storing our event path in that instance, setting up our parameter to change depending on one of our variables, which I'll talk about in a sec, and then playing it, okay? Which is what we did last time with the Footsteps event, but like I said, we've changed that. So in our if statement, we're checking for two booleans. One is called isGrounded, and the other is called wasGrounded. We're checking to see that isGrounded is true and wasGrounded is false. IsGrounded needs to be true because obviously we want to check if the player is currently touching the ground. If they are, that means isGrounded is true, and we want to proceed, with the playing the sound. WasGrounded, we want to be false. False, rather, sorry. So what wasGrounded does is it's basically checking to see if the player was touching the ground on the last frame. If they weren't, we know that they've just landed, because obviously they were in the air. If they were, that means they have not landed and they were just on the ground normally. So we don't want to play the landing sound if that is the case. So the way we kind of check to see if the player has touched the ground or not is like we did last time, which is with a raycast. So if I go to isGrounded, double click that, you can see I've created a special type of function here. This is called a method. The difference between a method and a function is basically a method, as well as performing any actions or behavior you tell it to, like you would in a normal function, it can return a value for you. So for example, in our case, I've replaced the word void with bool, meaning I want to return a Boolean value. I want to know whether something is true or false. And whenever I call this new method, I'm basically calling to check to see if, the bool is true or false. So isGrounded is, a bool. As you can see, the way I'm doing that is with another raycast, which is here. So just like the raycast we did in the last episode, we are calling a line, basically a little invisible line, that starts at the location of the player, shoots down by a distance of, I think I may have changed it, I can't remember if I did or not, but it's 0.05. It might have been 0.5 or 0.1 last time, I'm not too sure. But either way, it's casting down and it's using our layer mask to check that it hits the ground, basically, one of our ground objects. Cool. What I've also done is put the word return in front of it. And this is kind of how you return a value through a method. You write the word return, and then following that, you write what you want to use to determine its value. In my case, it's this raycast. So if this raycast hits a ground object, it's going to return the value of this boolean to true. If it's not touching anything, it's going to return it to false, which is a nice easy way to check if the player is grounded or not. So if I call this method and this raycast here is hitting one of our ground objects, isGrounded is going to be true. So whenever I call it or whenever I check it in an if statement, we'll get a true or false kind of thing. So that's how we check to see if the player is currently on the ground. We shoot a raycast, return the value of it, and whether it's true or false is tells us if we're grounded or not. However, we also want to check to see if the player was grounded in the last frame, if they were in the air or touching the ground. The way we do that is by creating the was grounded Boolean a traditional way. As you can see, I've done it up here, and as soon as we create it, I've set it to true, which will obviously change depending on whether the player is grounded or not. If I go into my fixed update function, this is where I was basically calling the isGrounded method. So every frame we're going to be checking that raycast to see if the player is grounded. However, just before we do that, we're going to be telling the code that the wasGrounded boolean is going to equal the isGrounded boolean. Okay, so let me quickly explain how this works. Every frame, the first thing we're going to do is basically set the wasGrounded boolean to that isGrounded boolean. So let's say, for example, the player's touching the ground. First thing we're going to do is say that, okay, wasGrounded will equal true because isGrounded is true, okay? Once we've done that, we're then going to calculate isGrounded to see if it's changed or not. So let's say that it's not, okay? So let's say the player's still on the ground. So in one frame, the player hasn't moved, they're standing on the ground. We know that wasGrounded is true because isGrounded is true, okay? Nice and simple. Now let's say in the next frame, the player has now jumped. So the player is now in the air. We go through our code, we come down to here, and like we said earlier, we want to set the wasGrounded boolean to whatever the isGrounded boolean is. Now currently, even though the player has jumped, the isGrounded boolean is still true because it hasn't been changed yet. We haven't called the method to check to see whether the player's in the air or not. So it's still true, meaning that wasGrounded is also going to be set to true. Next, after that, we then we then call the isGrounded method. So now we check that raycast, and it will check it and go, oh, okay, the player's jumped, so this is now false. So at the end of this new frame, wasGrounded is set to true, isGrounded is set to false. So now we can use that to say, okay, well, the player must have jumped. It also works the other way around. Let's say the player's in the air and has been in the air for a few frames now. Both of these booleans are set to false. Let's say that the player's falling down towards the ground. We check a frame and the player's still in the air. So wasGrounded equals false. wasGrounded we check to see if isGrounded is true or false. It's false. Therefore, wasGrounded becomes false. We then perform the isGrounded method. It fires the raycast and checks to see if the player's in the air or not. The player is not. Therefore, isGrounded becomes false. Then on the next frame, the player lands. So we check to see what isGrounded is, which is currently false, and we set wasGrounded to that. So wasGrounded is now false. We then run the method again, fire the raycast. Oh, the player's touching the ground, therefore isGrounded becomes true. So at the end of the frame, wasGrounded is still false, however, isGrounded is true. Hopefully you guys understood that. I understand it was probably very confusing, the amount of times I said grounded there. But the general idea is that we're using a Boolean to check whether or not our method is true or false before we call that method. And by doing that, when the next frame rolls around, we have a variable that's basically storing information that happened in the last frame, which is great for this kind of thing. We need to check, the difference between two frames. Notice how we've called the player landed function before we've done any of this as well. This is important because we want to check the previous frame before it gets updated and turns into the same as the current frame. Cool, so if we go back to the player landed function down here, like I said, as I've hopefully explained, we're checking to see in this if statement whether or not the player has just landed on the ground by checking the position of the player on the current frame and the last frame. Then if we go inside this if statement, we've got stuff similar to the last video, how we set up the Footsteps event. What we're doing is creating an event instance called landing and storing the event path inside it. Then we're setting our parameter called velocity, which I showed you earlier, and we're setting that parameter to basically measure the value of the height distance float variable. So let's have a quick look at how we calculate the height distance. The way I'm doing this is in another function called player falling check. If I quickly scroll up and go back to my fixed update function, you can see that player falling check is also being run every frame. So we're constantly checking to see whether or not, we're constantly checking to see how fast the player is falling. If we then go into the function, we can see how we calculate this. So what we're basically doing is using all three of those float variables I showed you earlier: height, old height, and height difference. If I then go back into it, you can see we're doing a similar thing to how we check to see whether or not the player was grounded or not. If the player was grounded or not compared to the last frame. As you can see, we calculate the level the player is at, or its height, by checking the transform.position of the y coordinate. So if I go into Unity and click on Ellen, we're basically checking for this value here, We want to know where our player is in the Y coordinate, and, you know, based on that, we know how sort of high up in the air they are. Before we set that variable's value, however, we are checking the last frame to see what the height value was. So just like in the last example, by setting the variable that checks the last frame to whatever the variable that checks the current frame is, before we calculate what the current frame is, we're able to create two variables that store values for both the current and the last frame. So let's say that the very first frame that is called, the player's Y coordinate is 0. We call the player falling check function. We then set the old height variable to the current height variable. Both of these at the moment are going to be equal to 0, as that's their default value. We then check to see what the player's Y coordinate is and store that within the height variable, which we know is 0. Then let's say the next frame rolls around and the player's Y value has now changed to 2. We set the old height variable to the current height variable, which is still 0, and we then store the new Y coordinate inside the current height variable, which is now 2. So therefore, the height variable is set to 2. So at the end of the frame, our old height variable is still set to 0, whereas our current height variable is set to 2. What we then want to do is calculate the difference between the two frames, and this difference is what we're going to measure for our velocity, essentially. When that difference is bigger, we know that the player is falling faster as the difference between the two frames has increased. So to do this, all we say is that the height difference, which is what we're going to store this value inside of, is going to be equal to whatever our current height is minus the old height. So going back to our previous example, if the current height was 2 and the old height was 0, we'd minus 0 from 2 and we'd end up with 2. Now, because that's a positive number, we know that the player has therefore increased in height. Now, in our case, we're not really interested in any values of the player increasing in height, essentially. We're after minus values, because minus values tell us that the player has fallen. Now, when I was testing this method, I did occasionally end up with some positive values, even though my player had clearly fallen. So a fix around this was this little if statement here. I said that if the height difference is ever greater than 0, I want to basically set its value to whatever the height difference was multiplied by -1. So let's say I had fallen and for some reason the height difference became 2. No idea why, but it happened. What I would then do is times that by -1, which would give us -2. That is then a minus number, so in FMOD, we can set that number onto our velocity parameter here. So let's go back to our player landed function. So we've set the velocity parameter to our height difference variable. What I'm also doing here is setting a new parameter called Footstep duck to measure the height difference variable inside the Footsteps event in FMOD. So if we go back to FMOD and open up the Footsteps event, you can see, as well as my material parameter, I've got a new one called Footstep duck. Now, what I found was when the player landed whilst the player was also moving, you'd hear the footsteps and the player landing sound at the same time, and that can sound a little bit muddy. So I wanted to basically duck this event down a little bit in volume whenever the player lands. Sadly, in FMOD, we can't kind of measure the volume of another event rather, and perform any ducking. You can do that in one event. Say, for example, I could duck the volume of the stone track by checking the volume of the earth track with sidechain compression. However, we couldn't do that between, say, the footsteps event and the landing event, which is what we're after. So to do this, we kind of have to use parameters and work it out in code. If I open up my master tab, you can see that I've automated the volume so that when the footstep ducking parameter is at 0, the event's at 0 as well. However, if the footstep ducking parameter is at -0.6, we get -25 dB. So the volume of this event will duck, basically, drop in volume. We then update this parameter whenever we're calling the landing sound. So if I go back into our code, we know that we're calling the landing sound within our player landed function. So whenever we do that, we want to write set parameter value for the footsteps at the same time. And this will update it. So whenever the player lands, we'll be checking the velocity or the height difference variable, and based on that, we'll update the footsteps ducking parameter I've just shown you. However, once we've then ducked the volume, we don't want that parameter to stay at that volume. If I go back into FMOD, Let's say that the player's just landed. We've played the landing sound and we've ducked the volume down to minus 25 dB. That's great, but how do we now get it back up to 0? Well, what we can use is basically a setting within any parameters in FMOD. If I click on the name of our parameter, is also called velocity. And what velocity does is basically you're able to set a specific amount of time to tell your parameter to return to its default value. So in my case, if I quickly return the parameter to 0 and right click, I chose to set 0 as the initial value because I don't want this parameter to duck, you know, as soon as the game starts. The velocity setting here will tell this parameter to return to its default value over a certain amount of time. And that time here is by 1 unit per second. So let's quickly test this out. If I go to timeline and add a loop region, I'm then able to just play the event constantly, so I don't have to keep playing it once and once, because over and over again rather, because it's a short event. And this will allow us to adjust the parameter and see what happens when we set a high value to our velocity setting. So if I click play, we can hear the footsteps playing. So let's go back to our footstep duck parameter. Let's click on it so we can see our velocity here. And if I change the value of the parameter to minus 0.6 and hit enter, you'll notice that our little cursor here went to minus 0.6 as it should, because I told it to, but then it returned gradually over time to 0. So now whenever the player lands, whilst the player is still moving, our parameter will move from 0 to minus, let's say 0.6 again, and the volume of this event will decrease. And then thanks to our velocity setting, over time it will then slowly increase again back to its normal volume. So let's go back into our code and have a look at the final parts of this code that I've set up. So once we've set both those parameters in both those events, we're then telling our landing event to start and release as soon as it's finished playing. I've also created a little debug.log command here so we can check the height difference and see how fast the player has fallen essentially, and how that will communicate inside of FMOD. And with that, I think that's everything in the code. So let's quickly hit Control S to make sure it's saved, jump back into Unity, and we can finally test out how it sounds within our game. Let's quickly hit play and see what happens. Right, so here we are inside the game. If I quickly come over here and just tap the spacebar to tell my player to jump, we hear a little landing sound. We also get a value down here, which was the height difference that we're sort of debugging into our console. So we get minus 0.04. So if we go into FMOD and have a look at our jump parameter, sorry, not that, the landing parameter rather, the velocity parameter, minus 0.04 would be all the way along here. So as we can see, we're only hearing the soft landing track here very quietly, which seems appropriate. If I then go back into the game and hold the spacebar, so now the player will be in the air for a bit longer and therefore fall quite a little bit faster, we get more of a thuddy kind of sound. And we also get a new value, minus 0.354. So if we go back into FMOD, we know that the cursor will have ended up around about here. There we are. And we would have got a blend of the two, hard landing and soft landing. So let's go back into the game. I'm going to find a big kind of jump for our player to fall off of so we can hear how it sounds when they're falling really fast. Okay, cool. So I found a big ledge for us to jump off of. As you can see, I've also got a load of values here as I was jumping around the level and landing. Different values obviously communicating different falling speeds. Let's quickly jump off and see how hard we fall, basically. There we go. So we got a nice big thud sound and we got a value of, wow, -1. So if we go back into FMOD, obviously the cursor's gone right the way over as far as it could. And we got basically all of the hard landing audio file and barely any of the footsteps landing. I've also boosted it a little bit over 0 dB so we can, you know, really hear it. I've also added, as you can see here, a little EQ to the hard landing track, which I was tempted to kind of boost the low end, and I might go back and do that. But for now, I'm quite happy with where it is. Here's another example of the player landing as well. If I quickly walk down these steps. So there we go. Hopefully, it's kind of a subtle effect, but hopefully you could hear both the landing and the footstep sounds without it being too muddy. Cool, and there we go. So that's pretty much everything we wanted to do in this episode, and also that's pretty much everything we want to do around the player character. Like I said, I might go back and add the jumping sound, but for now, say if I'm running around, for example, and start jumping, I kind of feel it doesn't really need anything at the moment. If there was any more kind of fuddy footsteppy sounds, I feel like it would be too much, like I explained earlier. But yeah, so to recap where we're at, we've got the melee attack, we've got the gunshot sound, which should sound, or the bullet rather, should sound like it's coming from either the left or the right side of your headphones or speakers, depending on the direction it shoots. We've got a jump sound. Sorry, we don't have a jump sound rather, but we've got footstep sounds that change depending on what material we're walking on. We've got landing sounds, as we can hear here. We've got nice soft ones if we do little soft jumps, as well as heavy ones if we hit the ground quite hard. And if we take any damage, we've got a little sort of pain sound. And yeah, that's pretty much it. So hopefully we can start moving on to some different sounds, some maybe enemy sounds or environment sounds. I'm not too sure yet what we'll do. But we're definitely still in that stage of just implementing sounds and making sure they all work. And I think with that, that's everything I wanted to show off in this video. So cool, we're getting there. So thank you very much for watching. Let me know if you've enjoyed this and if you have any suggestions or things you want to see as we progress, any particular sounds that you want me to implement. Like I said, probably just stick with sound effects for now and maybe, get into more mixing stuff and some music as we go along. But feel free to let me know in the comments. Like I said earlier, keep an eye out for my FMOD and Unity Fundamentals course. I'm going to be posting updates on Twitter and on YouTube. And yeah, I think that's everything we needed to know. I'm trying to think off the top of my head if I'm missing anything. I think we're good. Great. So, as always, I've been Henry Scott. Thank you very much for watching.